All right, what up, everybody? Today we're going to be talking about how to go from a position versus time graph to a velocity versus time graph. So we're just doing this qualitatively, no numbers involved, but we're going to kind of show you how you can look at the shape of a position graph and tell something about the shape of a velocity graph. So first of all, just some rules about position graphs. You can tell the velocity of a position graph because velocity is equal to slope, which means if you have a positive velocity, you should see a slope that goes up like this. If you have a negative velocity, you should see a slope that goes down. And if you have no velocity, if something's not moving, then your slope of your velocity of your position graph is going to be flat. Okay, so looking at the way the slope goes, you can tell whether it's positive, negative, or no velocity. You can also tell the acceleration of a velocity graph. Anytime the velocity graph curves at all, there's going to be some acceleration. It's not going to be zero, right? And there's a rule that says that if the curl is upward, then the acceleration is positive, and if the curl is downward, then the acceleration is negative. Okay. Some people like to say that a smiley face is positive, a frowny face is negative. So that doesn't sound very scientific, but it's actually true 100% of the time with position graphs. Okay, if you can imagine your graph being part of a smiley face, then it has uh, positive acceleration. If you can imagine it being part of a frowny face, then it has negative acceleration. So if you have straight lines on your position graph, either it could be straight like horizontal or it could be straight diagonal. Either way, it's showing that you have no acceleration. Your acceleration is zero. Okay, velocity graphs, on the other hand, have their own set of rules. Okay, so in a velocity graph, to tell whether the velocity is positive or negative, you'd look at what side of the graph it's on. So if it's on the top half above the zero line, and this is a zero line right here, then it must be positive velocity. If you have if your graph is on the bottom half, it must be a negative velocity. Oops. Now, acceleration you can also find on a velocity graph because it is equal to the slope. So just like velocity with the slope of a position graph, acceleration is the slope of a velocity graph. So that means if you have velocity that's going up, it must be a positive acceleration. If you have velocity that's going down, it's negative acceleration. If you have a flat line on your velocity graph, it's zero acceleration. Okay, so let's practice. We're going to look at a position graph, look at a few things about it, and tell what the velocity graph looks like. So you'll notice that this position graph, it must be moving away, okay, because it goes higher, it gets away from zero as it goes from left to right. So it's an object that's moving away, which means on the velocity, you'll have the velocity will be in the top half of the graph. Okay, so it's because it's a positive velocity. We also notice about this position graph on the left side that it curls upward. Okay, so the curl up is a positive acceleration. It's part of the smiley face. And so on a velocity graph, that means that this line is going to slope upward. Okay, because it has positive acceleration. This one starts flat and ends steep, which means the velocity moves away from zero. Okay, so remember a flat line on a position graph means no velocity. So the closer the line is to being flat, the less velocity it has. It's going slow. Whereas if it gets steeper and steeper, it's going fast. So we can tell for sure that whatever this velocity graph is good. The line's going to be in the top half. It's going to be sloping up and moving away from the zero line. So there we have it right there. It would have to look like that. Okay, next example. In this case, the um, the position graph is moving away from zero, so that means a positive velocity. So this velocity graph will have its line in the top half of the graph. Okay, this position graph also curls downward. So this would be right, so it's like the right half of a frowny face, which is negative acceleration. Okay, because of that, on the velocity graph, we expect to see the negative acceleration, which means a slope going down. This one starts steeper and ends flatter, which means the velocity graph needs to move towards zero. So it's going to be in the top half, the velocity graph is. It's going to slope down and it's going to move towards zero. So what would that look like? It would look like that graph right there.